Welcome back at BartlikBartlik YouTube channel, and please continue subscribing for more construction basic knowledge. Today we are going to take ourselves through some checks on how to check whether a retaining wall will undergo a failure of sliding, or how to check if a retaining wall will give in to sliding failure, or it will be able to withstand that sliding failure. So we will have our structure here. This is our illustration, and from our illustration we have the stem, the heel, and the toe. So our illustration here, we have the stem has got a height of 3 meters, and then the base has got a height of a half a meter or 0.5 meters, and then we have the length of the base. So the length of the base, which consists of the heel and the toe, it is 3 meters, whereby we have 1.5, 0.5, and 1 meter. So the total length of the base is 3 meters, and the total height of the wall will be the height of the stem plus the height of the base, which will be 3.5 meters. Remember, we have a note here. We have been given that the load characteristic, the dead load characteristic to be taken into account shall be 0.9. So we'll be using this 0.9 at some point in our calculation, which is a dead load characteristic. It has to be taken into account. So we want to check whether this structure of ours, this retaining wall of ours, will withstand sliding as a failure, or the sliding will be able to take place. So we have factors that we have to consider. We have factors that we have to put into account, that is in our calculation, whereby we need to know, or rather we need to have the concrete unit weight. So our concrete unit weight is 25 kilonewton per cubic meter. That is the concrete unit weight, or the concrete density is 25 kilonewton per cubic meter. And then we have the soil density, which we have been given as 19 kilonewton per cubic meter. So that is the soil density, or the soil unit weight, 19 kilonewton per cubic meter. So that is what we have been given. That is in our illustration here. And then we have coefficient of friction, that is between concrete and the soil. We have coefficient of friction. Remember that friction, when sliding takes place, sliding is a movement. So when sliding takes place, there will be that friction that will be created between the soil and the concrete. Remember, this friction will be created at the base, that is under the base, and here under the base, that is where we have that concrete and soil. So if sliding occurs, so during that movement, there will be that friction that will be created, that is between the soil and the concrete. So that is what we have here, coefficient of friction. So we have to use this friction coefficient, which we have been given as 0.45 in our calculation. We will be using this friction coefficient. And then we have the active pressure coefficient, coefficient of active pressure, which we have been given as 0.3. So let us jump into it and see whether this structure will be able to withstand sliding as a failure, or it will give in to that kind of failure. So in our calculation, we will start by determining the sliding force calculation. So we want to check the sliding force calculation. So the sliding force calculation, we have to determine the earth pressure of the base. So the pressure that will be acting at the base, we have to determine it. So we will take 19. Remember 19, this is our unit weight of soil, or our soil density. So we will take 19 multiplied by into brackets 3 plus 0.5. So why are we adding 3 to 0.5 into the brackets? Remember, according to our illustration, the height of the stem is 3 meters and the height of the base is a half a meter or 0.5 meters. So for us to get the total height, the HT will be 3 plus 0.5. So that's why we have 3 plus 0.5 in the bracket. So we are multiplying 19, which is the unit weight of soil or the density of soil, multiplied by the what? The total height of the soil, which gives us 66.5 kilonewton per meter. So 66.5 kilonewton per meter, that will be the earth pressure of the base, at the base. That will be the earth pressure that will be acting at the base. And then we have to get the total earth pressure force. So the total earth pressure force will be 0.5 multiplied by 66.5. 66.5 is our earth pressure that we have found here, multiplied by into bracket again the total height of our retaining wall, which is 3 plus 0.5. So the total earth pressure force is 0.5 multiplied by 66.5. So 66.5 is our earth pressure at the base, and then multiplied by the total height of our wall, that's the stem and the base. So we get our value to be 116.37 kilonewton. So that shall be our total earth pressure force. Okay, now let us come to resisting force calculation. We want to now to calculate the force of resistance. So this force of resistance, we have to determine it, or we have to get it by, we will determine our dead weight, or we will determine the weight of the structure. That's what we refer as the dead weight. So the weight of the structure, we will take 25. Remember, this 25 is the concrete unit weight that I showed you here. The concrete unit weight is 25 kilonewton per cubic meter. So for us to determine this resisting force calculation, that is to determine the dead weight, we will take the unit weight of concrete, which is 25 kilonewton per cubic meter, multiplied by into the brackets 3. Remember, that is the height of the stem. That's the height of the stem, multiplied by 0.5. We are assuming again that the thickness of our stem is, you can see from our illustration, the thickness of our stem is 0.5. So that is the thickness of our stem, is 0.5. So it is 25, which is the unit weight of concrete, multiplied by into bracket 3, which is the height of the stem, multiplied by 0.5, which is the thickness of the stem, plus 0.5 again, which also we assume is the height of the base, multiplied by 3, which is the height of the stem. So I have said we will take 25 kilonewton, which is our unit weight of concrete, multiplied by into brackets 3, which is the height of the stem, multiplied by 0.5, which is the width of the stem, plus into brackets 0.5, which is the height of the base, multiplied by multiplied by 3, which is also again the total length of our base. Remember we said 1.5 plus 0.5 plus 1, that is the total length of our base, which is 3. So 3 multiplied by a height of 0.5, and then we are multiplying by the unit weight of concrete, which is 25. So remember, that is the area, or we assume that is the volume of the base. Remember, we are calculating everything per meter length. So that's why we are using 1. So it will be this area, the area of the base multiplied by, we are assuming it is per 1 meter length run. So it will be this area multiplied by 1. So it is 3 multiplied by the height of the base multiplied by 1. So that's why you can't see the 1. Again, the stem, it will be 3 multiplied by the thickness of the stem multiplied by 1. So that is the volume of the structure, and then multiplied by the unit weight of concrete. So we get our total weight to be 75 kilonewtons. So this will be the dead weight of the structure, or this 75 kilonewtons shall be the weight of the structure rather. So 75 kilonewton. And then now we have to determine the soil weight. So remember again, we said 19 kilonewton per cubic meter, that is the soil density. So we have to determine the soil weight. So the soil weight shall be that shall be acting on the stem. It will be 19, which is the unit weight of the soil, multiplied by 3, which is the height of the stem, and then times 1. So remember, 1 is 1 meter length. So it will be 19 times 3 times 1. 3 is the height of our stem, and then 1 is per meter length. So the total soil weight shall be 57 kilonewton. So let us now see the total resistance force. So therefore, our total resistance force, remember from this note we were told that the dead load characteristic, which is 0.9, shall be taken into account. So we are now going to use our 0.9 here. So 0.9 multiplied by 0.45. Remember, our 0.45 is the friction coefficient. Friction coefficient 0.45. So 0.9, which is the dead load characteristic, multiplied by 0.45, which is the friction coefficient, multiplied by, into brackets, 75 kilonewton, which is the dead weight, plus 57 kilonewton, which is the total weight of the soil. We get our answer as 53.46 kilonewton. So that shall be our resisting force, 53.46 kilonewton. So we are being told that the resisting force, it should be 1.4 times the sliding force. Our resisting force should be 1.4 times the sliding force. Then we will know that our structure will not undergo sliding. But if it is less, then our structure will undergo sliding as a failure. So therefore, how do we determine this? We determine this by, we will take our total resisting force, we divide against our total earth pressure force. So our total resisting force, our value was 53.46, and then our total earth pressure force was 116.37. So we will divide 53.46 against 116.37. We get our answer as 0.45. So remember, we were told that it should be at least 1.4 times higher than the sliding force. So 0.45 is less than 1.4. Therefore, this structure will undergo sliding. Therefore, this structure will undergo sliding. our retaining wall will be able to undergo sliding. It won't be able to resist sliding as a failure. So that is how we check whether our retaining wall will undergo sliding as a failure or it will be able to withstand that failure. Thank you. Please like, share, and comment.